Welcome to our social impact, brought to you by the Prison Scholar Fund, that has a mission of providing education and employment assistance to help incarcerated people succeed and thrive in society while avoiding homelessness and the revolving door of incarceration. As a nonprofit, we rely on investments, board members, and volunteers. So please connect with us. Visit our website, prisonscholars.org. Send us an email at info@prisonscholars.org. You can find volunteer opportunities, learn about becoming a board member, and make an investment on our website. You can also make an investment through Patreon, where you can find us at Prison Scholars. Without further ado, welcome to the next episode of our Social Impact. Thanks for joining us. Today we have NOAA and Commitment Israel with 3D Sustainable Development. And they have a really cool product that we'll talk about today about basically printing houses with recycled concrete, so to speak. It's a lot more complicated than that. So I'll let you tell me all about it.
Great. Well, thanks for having us today, Dirk. We really appreciate having us on. Like you said, we've built a large-scale 3D printer for printing sustainable housing and infrastructure, and it uses our own formulations of high and ultra-high performance concrete that can contain up to 60% waste material.
So when you talk about 3D printing, my mind goes to those little desktop 3D printers. Is this the same kind of printing, just bigger for a house?
Basically with some optimizing adaptations to particularly address the architectural direction that we've chosen to print large-scale domes. So it's 44 feet in diameter and approximately 25 feet tall.
Now, are they all 44 feet, or do you have different sizes?
At this point, we only have the one size, and we are, as we grow, we'll branch out into larger thing. We have a patent that was issued to us this year for the variety of sizes, so it's not limited to that particular size, but that was our prototype size.
Okay.
And so the houses themselves don't go up to 44 feet in diameter. The max house size we can do on that printer is 38 feet in diameter, and that can be up to, or just over even 1,800 square feet of living space.
Okay. And how did you come up with this idea?
Well, I was hired to do material development and technology applications in Ghana a number of years ago, and seeing the lack of talent in the age range that could really address the scope and scale of the housing need in Ghana. At the time, they were needing over 1 million homes to simply address their fundamental needs, and government workers were living in very substandard housing, even though they were being paid by government. So I was hired to go to Ghana and study the situation. I was toured by the housing ministers in the country and got to experience a wide variety of situations. Having been in CNC manufacturing in my past, and at the time as I was working with these highly reactive concrete materials, one thing led to another, and I realized that we could address the housing need by doing large-scale 3D printing before 3D printing was a thing.
Oh, interesting.
And do it using a lot less labor, because like he was mentioning, there's a real gap in their population. They don't have the same labor force due to war and AIDS.
Yeah.
So they're missing a whole generation, basically.
So really needs to be automated then.
Yeah, so using automation allowed us to address the large numbers needed with a relatively small workforce, and re-empower village life, which was our particular focus. Most of the construction coming into the country was mostly focused on the large cities, and creating a major lack of infrastructure in villages, which is where most of the population lived. And so it was displacing those populations by lack of housing and infrastructure. So we were looking to address that specifically.
So the Ghanaian government did issue us an MOU, or a memorandum of understanding, for 10,000 houses with an opportunity to increase to 50,000. But this was just back when he was developing the idea and the concept, so we didn't want to dive in to go from 0 to 10,000.
Gotcha.
So anyway, we've been working at getting the company together, develop the materials and the technology over the last 10, 15 years, and
so it sounds like you have an edge on the technology. Tell me about the materials. You do something unique there too.
Yeah, we've been using high strength and ultra high strength concretes that are 5 times or more the strength of typical construction grade concrete.
And by using, he means been developing recipes.
Yes, and test and using them in test building. So.
Yeah, I heard some of it is sustainable. So do you recycle concrete, or what
Well, we can recycle a variety of materials, and we're selective at this point. But ultimately, we can address large streams of various sources of waste streams, mining wastes. And all the way to municipal wastes in various forms in isolation. So we can recycle glass, we can mine tailings, which are a major problem around the world. There's tens of thousands of sites that have large waste piles.
And all of this can go into your concrete mix.
I can't say all of it,
or
but large volumes of it, millions upon millions of tons.
So we're looking to partner with industrial waste producers, large-scale industrial waste producers, and mining operations and remediation organizations to address these large-scale deposits of waste and streams, and to convert them into our high-performance concretes, basically on site, or close to where they are being produced.
Yeah.
Okay.
I had been in the construction business for most of my life, since I was a teenager, and one thing led to another. And as I was transitioning from the previous company I worked with, I was looking at how we were going to evolve in sustainability, that being forefront in my mind in moving forward, and seeing the state of disposable housing that we have been building and are currently building, to economic life of housing being 65 years. That didn't seem as sustainable as some of the ancient constructs that lasted thousands of years. So that's what piqued my interest. As I got deeper into studying the current state of our infrastructure and housing, that it needed some further attention. And I wanted to devote myself to addressing those fundamental issues and problems that cause us to not have legacy housing, where for the last thousands of years, that's what people focused on, was to be able to pass on their housing infrastructure, and therefore relieve the financial burdens on their generations by building structures that lasted a really long time. And so that's what was motivating me. And
And so commitment, how did you get involved? You just fell in love with what Dad was doing?
Well, growing up with my father, I have always had an interest in sustainability and specifically sustainable building. I dove in, realizing that I had a good mentor say to me noted to me how much I light up when I talked about what my father was doing and how he was building this new technology. And on my 28th birthday, inspired me. He said, that you really should go into business with your father. The way that you light up when you talk about what he's doing says that you...
I think you make Dad proud.
Yeah, I don't know if he knew this story.
He does now.
But
that's beautiful.
so that was it. On my 28th birthday, I had that advisor be like, "This is what you should do. Look no further." And I said, "You're really right."
So I love it. I love the sustainability angle. I love the passion. Tell me about the business sense.
Aw,
Tell me about the business model behind this.
Well, I couldn't be more impacted by imparting a love and desire to impact people's in a supportive way, and it's been my life is to create sustainable village environments, and so that would really address major life support issues and relieve those as much as possible in my life. And so to have my daughter make, whose name is commitment, to make a commitment in her life to that same purpose is very humbling and inspiring.
I like it. That's so great. So what's the cost to build one of these houses?
Well,
and how do you
the first one has been over $1 million.
I can imagine.
Well, that's developing the machine,
the technology.
Yes,
so it's really an in-depth question
because of scope and scale.
You have a lot of in startup costs.
Yeah, we have a lot of startup costs at this point, but as we get into larger projects and the technology maturing, that'll help drive the costs down further. But at this point, we're targeting roughly 35 to 40% less than conventional construction costs.
And that's here in this market.
In this market.
So we're looking to hit the global market and get our costs down for a 500 square foot structure. We want to hit the United Nations target of $35,000 for a completed structure, and that's at 500 square feet. So as we mentioned, our machine can do much larger houses, and then the local market, most people don't want a 500 square foot house. Even though there is a tiny house movement, but really, that's too small for in this market for most places. But globally, when we're looking to address, several hundred to several thousand house contracts, we're going to be working at that $35,000 goal for completed turnkey structures on that scale.
Okay. And they kind of describe how the construction process works, and the people that are watching this on the video, they can see an overlaid video of it going on, but the people just listening, you can kind of describe what it looks like, or how the process goes.
The process is basically a cleared site. We excavate for a ring beam and cast a slab-on-grade floor system, and then attach an inflatable form to that structure, and install our rail system, which is the assembly of the printer itself, which has taken 4 to 6 hours to assemble on site, and we inflate the inflatable structure and begin print. And within a few hours, we build up the structural form of it and add insulation and a final coat of the finished outer surface.
So it sounds like you have kind of an inflatable bubble on the inside,
Mm-hmm.
and then does a person spray the concrete on top of it, or is that a robot arm?
No, that's a robotic system.
Yeah, and the nozzles move at 2.5 feet per second, so it's really laying a lot of material. That's how we can get a completed structure in under 8 hours.
Of that size.
So I'm just imagining that the concrete would like drip and slide down the structure. Is it really fast setting, or like once it's on, it's kind of on?
Yeah, that's part of our formulation evolution, was to create material that would allow us to apply materials in a sequence that would self-support
Really quick setting.
in quick setting.
So earlier, Commitment was telling about the strength of your concrete. Maybe run that down real quick for the people that don't know anything about concrete.
Mm-hmm. So regular concrete has an average of 2,800 to 4,000 psi. That's or pounds per square inch of compressive strength. So
And
that's kind of a measure of strength for concrete.
Is that the concrete you see on sidewalks and
Correct.
things like that?
Correct.
That would be more on the lower end of that for sure. We
Yeah, that'd be
wouldn't
in
be up
the-
at 4,000 for sidewalks. But so anyway, so that 2,800 is more like the average concrete pounds per square inch. That's a compressive strength. So then that's that rating is how the other grades of concrete are rated there. So then we have our recipes are high performance concretes. So that's anything over 8,000 psi, and our regular recipe at the high performance concrete is at 15,000 psi. So it makes it's at least 3 times greater strength than regular concrete. And we also have recipes that fall under the category of UHPCs or ultra high performance concretes, and that's anything over 17,000 psi. And so we have our recipes up in that grade that go up to 25,000 psi. So that's the real specifics of it. But basically, what that means is that they have far greater durability and longevity to be able to withstand natural disasters and just the wear and tear of climate, general climate as well.
And addresses corrosion issues, which are prevalent in even bridge construction. It's one of the major downfalls of our infrastructure to date has been the corrosion issues, and so we've addressed these formulations so that they're not impacted by typical corrosion we see in the industry.
So what kind of supporting structures are inside the concrete? Do you guys use rebar in the process?
No, we don't. We use fiber reinforcing that are particularly high strength and basalt passive reinforcing to address the code issues that are typically required to have for structures.
So concrete is typically reinforced with rebar, but it's actually one of the weak links of concrete, being that most concrete is permeable, meaning that the water can get in, and that ends up being the weak link. When the water gets in and rusts rebar, it causes oxidation and expansion, and that causes cracking and crumbling. So that's called concrete cancer, and that's one of the key issues in why we have so much crumbling infrastructure is the penetration of water
Or vapor.
Or vapor, getting in and rusting rebar and causing that the cracking, and then also the water getting in through those pores also causes freeze thaw, which is when the water gets in, freezes, and it expands again and causes the crumbling and cracking. So with our recipes being very near impermeable, or essentially impermeable, it negates a lot of those issues.
That's fascinating. So it sounds like you kind of started off with building these houses, but there's a huge market for your concrete.
Yes, and the industry is very, very slow to adopt new materials in the construction world. So a product introduction cycle is very quick at 20 years.
Wow.
So
That's why we're looking to just
typically,
put
in the past.
put our concrete mixes to use ourselves,
Directly.
deploy them with our 3D printers. And so we're also looking to license our technology the world over to developers and engineers qualified, anyone qualified that's looking to do large-scale development, so that will be a channel for our mixes as well, so we can sell them to our licensees.
So it sounds like you have the first mover advantage, maybe by a pretty good gap. Is there anybody behind you, or who else is in the space doing similar work?
There's an increasing number of larger scale construction startups. I know of probably 10 of them that are at different stages of it.
Well, it really
We've
depends.
addressed a particular.
Sorry. It really depends on which market you're looking at. Because if you're talking about concrete specifically or 3D printing, there's
a lot of overlap between
Yeah.
your technologies.
Mm-hmm. Yeah.
Yeah. So high performance concretes definitely exist and are on the market. We just we have formulations that bring them down to more comparable in cost to
More affordable.
Yeah.
To applications like this.
But yeah, you want to talk about 3D printing, the competitors in the space, or we like
Sure.
to think of anybody doing it more as helping pave the way, because there's a long way to go in building, and there's a lot of barriers with the permitting and
the regulatory process, and the need for high quality, low cost housing is massive beyond any one of us addressing it completely, so to even have a very small percentage of the market is a huge challenge, no matter who you are.
So we have, United Nations Habitat estimates that we need 3 billion new houses in the next 10 years, which is
Really?
an astounding number of houses. It's 3 times more houses than we as a human race have ever built, and we need that in the next decade. When you break it down, that's an addition of 4,000 houses per hour need to be being built.
So how much of that market do you want?
Well, we want to help facilitate as many families as possible to be adequately housed. So however we can accomplish that with as many participants and cooperators as we can.
And licensees. And licensees.
And licensees is what we'd like to accomplish.
So where are you at now? Where's your traction or your progress? Do you have any?
Well, we have our first licensee to address First Nations housing in Canada. And
we have a pilot project for that, a 6-house pilot project for elder housing for a First Nations tribe up there. That project has been submitted to the Canadian government, call for innovative solutions for funding for that project. So we should find out next month if our licensee got the funding for that one. So that's an exciting piece. We have a second licensee is in LOI, or letter of intent. He's been building concrete dome housing by hand around the globe for a number of years.
Hundreds of units.
Wow.
Large scale.
Without the machine, same concept though.
So he's been chomping at the bit to get one of our machines, or at least one of our machines, for a number of years. So he's happy to see where we're at. We're just about to dive into manufacturing of our machines.
He basically demonstrated to me that the market was very large, and he spoke to that directly and demonstrated that it could be done even in the most remote locations.
And has witnessed the need the world over. He's traveled to many countries and has had several countries offer sovereign guarantees. So that's one of our next pieces. We're going to try and figure out how to get sovereign guarantees bonded or financed. And we also, like I said, we had the big project from Ghana as well, where they wanted to offer a sovereign guarantee. So that's going to be a big piece for us is figuring out how to get those massive contracts financed.
So speaking of financing, how do you pay for all this? How do you pay for moving forward until the traction hits? Do you have investors on board, or is this all bootstrapped?
We've done a lot of bootstrapping. We've had friends and family. We've personal investments, and
the typical startup sound.
Yeah.
And then we've just launched into raising our first round of investment funding.
And got our first independent investor, interestingly enough, who's a mechanical engineer and builder.
Nice.
And
so a lot of people ask, why domes? Why we start with that structure. That
I was
shape.
actually going to ask you why the dome.
Yeah. So the first piece is the durability of the shape. That shape can withstand natural disasters, earthquakes. It disperses impacts very well, so it's able to withstand.
Yeah. The Romans have been doing arches for years.
Yeah, and it has very high resistance to winds because it doesn't behave like a sail. It behaves more like a wing. So high winds get deflected.
So it can withstand the tornadoes and hurricanes.
And it's fire, not entirely fireproof, but fire resistant to normal forest fires and that kind of thing, grass fires.
Yeah, being a concrete dome, I would imagine.
Yeah.
So another reason why we went with the dome was to be able to address the roof issue. So to be able to go straight from wall to roof in a continuous piece of concrete, all bonded together. Very strong shape, and also does not have that the fire
exposure. At the wall roof juncture is a weak point in most rectilinear constructions. So it addressed our ability to be able to 3D print this in a first generation and create a viable and valuable product that would be highly resistant to natural forces. So that was the combination of design criteria that we were addressing, and we were able to accomplish that. We're looking for sustainable people that have the same desire for social justice and are looking for to join us in bringing the technology to full fruition on all levels.
Hit the other side of the market.
Yeah.
So that's kind of interesting too. It's like it sounds like a really great product, but what's the consumer sentiment? Like people that want to buy these houses, do a lot of people want to live in domes, or
we don't need we don't need everybody to live in domes. We've had our prototype dome that we've had hundreds of people tour through, and the vast majority of them love the feeling of it. Say, I want one of these. I've heard that dozens upon dozens of times walking into a dome structure. So
a pretty good market.
Yeah.
And we also have had so much interest just come through our website with no marketing of our website, but just so much interest from people that want us to just build a single family home for them. So we feel those calls all the time that's not what we're doing at this time. So, but it does speak to the market and the general desire for a more sustainable structure, and people really like that dome shape. But so what we're doing right now, we're looking to do development scale. We're business to business, looking to connect with governments and affordable housing organizations and other developers, particularly in natural disaster prone or stricken regions that want to build large-scale developments.
And that will allow us over time to address the single house or cluster housing market as we have more depth of capacity to be able to address those.
And are these single stories, or like is a dome big enough you would have maybe a layer on the inside with the second floor?
Yes. The larger, so the 1,800 square foot structure, that would be with a second floor.
So what are your current needs? What do you need to get this thing off the ground in a way that you're happy with?
Well, first we're diving in, like we said, to this round of funding to get us through phase one. We're doing 2 rounds of funding, and that's to launch our manufacturing facility. We do need a couple key people. Do you want to speak to? Well, we need a whole list of people.
We have a whole. We are definitely looking for talented folks with the right spirit to help really bring this to fruition.
So what kind of people do you need to get on the bus?
Well, from programmers to millwrights to assemblers and people willing to travel.
And then we do need a few members for our concrete
production.
Our concrete
side.
Production and mixing and precasting.
Mm-hmm.
So there's a.
So anywhere from IT, engineering pros, computer people,
Mm-hmm.
all the way to construction professionals.
You got it.
Fascinating.
And international sales.
And international sales.
Yeah, I'm keeping my eyes out for sure for someone who has construction experience or
some biz
development.
dev.
Yeah, development sales. So that's.
Well, awesome. Noah, commitment, thank you so much. I'm excited to see what happens next.
All right.
Thank you.
Thanks so much for having us, Dirk.
All right.